This is a video walkthrough for practice 7E. In number 1, we're asked why negative b is used to help find answers when looking for a maximum or minimum. For any quadratic function in standard form, or y equals ax squared plus bx plus c, negative b over 2a is the x value of the vertex. The vertex of the graph of a quadratic function, which is a parabola, will either be a minimum point or a maximum point. In 2 through 11, we're asked to write equations and use it to answer each applied minimum or maximum problem and show our work. We have a rectangular region in number 2 that's enclosed using 80 feet of fencing. When we talk about fencing, that's going to go around the perimeter of a figure, in this case a rectangle. So if the width of the region is x feet, we want to write an expression for L, the length, in terms of x. Since we have a perimeter of 80 feet, since we have 80 feet of fencing, that means that 2x plus 2L will equal 80. Everybody's divisible by 2, so we can divide both sides by 2 and get x plus L must equal 40. And then if we solve that equation for L by subtracting x from both sides, L will be equal to 40 minus x. In B, we're asked to use the result from above to write an expression for the area in terms of x. So area is equal to the product of the length and the width, so it would be x times L, or area is equal to x times 40 minus x. So we have an area function that's described entirely in terms of x, not in terms of that other variable L. If we want to put this in standard form, we can. When we distribute, you'll get negative x squared plus 40x. I've changed the order of the terms so that it is in ax squared plus bx plus c form. And remember, c is actually 0 since there's a plus 0 on the end. So using that result from above, we can find the dimensions of the rectangle of maximum area. So negative b divided by 2a is equal to negative 40 divided by 2 times negative 1. So that's going to give us a value of 20. And this is the x value at the vertex. So the dimensions of the rectangle are x and L. So x, the width, is equal to 20 feet. Make sure that you give units on that. And the length is equal to 40 minus 20. 40 minus x, remember, is the length. And so 40 minus 20 equals 20 feet. Generally speaking, we give our answer in this kind of a form when you ask for dimensions. 20 feet by 20 feet are the dimensions of this rectangle of maximum area, which is a square. Now we're going to find the maximum area of the rectangle, and that maximum area is the length times the width, which is 20 times 20, or 400 square feet. Again, make sure that you're giving appropriate units. Units of area are measured in square units. In number 3, a woman wants to build a rectangular enclosure for her dog using the side of the house and 22 feet of fencing for the remaining 3 sides. So in our diagram, we can see one side that's labeled X, and the opposite side of that rectangular enclosure will also be X. Let's call the other one L. The width of the pen is x feet. Write an expression for L in terms of x. Since that 22 feet of fencing is only required for 3 sides of this enclosure, that means that we have 2 widths plus 1 length, and that total is going to equal 22. If we take that equation and solve it for L, L will be equal to 22 minus 2 times x. And using that result from above, we can write the area in terms of x. Area is equal to the product of the width and the length, so x times 22 minus 2x. And you can either leave that in factored form, or you can rewrite it in standard form if that makes it easier. I'm going to change the order of the terms as I write that in standard form and write the x squared term first, since that will now be in standard form a equals ax squared plus bx plus c. Using that result, we're going to find the dimensions of the rectangle of maximum area. So the dimensions of the rectangle of maximum area will happen when x is equal to negative b divided by 2a, and the opposite of b is negative 22, and 2a is 2 times negative 2. And so that's going to give us a result of 22 divided by 4, which is 5.5, and that would be feet, right, because that's our width. Now let's remember that our length is equal to 22 minus 2 times x, so 22 minus 2 times 5.5, that's 22 minus 11, which is 11. So our dimensions are 5.5 feet by 11 feet. Dimensions refers to the length and the width. Now we're finding the maximum area of the pen, which would be the product of the length and the width, 5.5 times 11, which will equal 60.5 square feet. Remember that when you are giving units of area, they're going to occur in square units, so make sure that you are clear that your answer is measured in square feet. You can write out the word square feet, or you can use the abbreviation feet with the exponent of 2. All right, in 4, we have a farmer who wants to fence in 3 adjacent corrals, and we're using 120 feet of fencing. However, not only do we have the length and the width, but we have these interior divisions here that are going to need fencing. So we have 2 lengths and we have 4 widths. So what we do know is that our 2 lengths, miswrote that, 2 lengths plus my 4 widths should total the total amount of fencing, which is 120 feet. Let's divide everybody by 2. L plus 2x is equal to 60. So that means that L is equal to 60 minus 2x. So our area function is area is equal to the width times the length. So that would be x times 60 minus 2x. And that's in factor form. If you want to rewrite that in standard form, it is negative 2x squared plus 60x. And so using that area function, our max is going to occur whenever x equals negative b divided by 2a. So negative 60 divided by 2 times negative 2 is 60 divided by 4, which is 15. So that's going to give us that width of the corral, and now we need the length, and remember that the length is 60 minus 2 times the width, or 60 minus 2 times x. That's 60 minus 30, which is equal to 30. And so what are we looking for? We are finding the maximum area, and we are also finding the dimensions that will produce maximum area. So we're actually looking for 2 different things. So we are looking for the width and the length. So dimensions are going to be 15 feet by 30 feet. It doesn't matter which one of those comes first. And our area is the product of the width and the length. So that's 30 times 15, which would be 450 square feet. Remember, dimensions have linear units on them, in other words feet, and then the area will have units that are square units, so square feet. All right, let's talk about toys. In number 5, we have a toy that is priced at $30 a piece and has annual sales of 4,000 units. In other words, 4,000 of those toys are sold. The manufacturer estimates that for each $1 increase in cost, the annual sales will decrease by 100 units. So let X be the increase in price. So those are $1 increases in price. So the price of our toy P is going to be equal to the original $30 plus however many dollars are added to the price. And now we're going to write an expression for the annual sales, or the number of units that are sold. So their original price here was 4,000 units, or rather the original amount of toys that are sold is 4,000. And for each $1 increase in cost, they are going to decrease the annual sales by 100, so 100 times x. In other words, if we increase the price by $1, we're going to decrease the price by 100. If we increase by 2, then we decrease the price by 200. And since revenue is total annual sales in dollars, revenue is the price times the number of sales, or the number of toys sold. And so we're going to use those two things to write an expression for the revenue, R. So R is equal to the product of those two things, so 30 plus X times 4,000 minus 100X. And that's in factored form for us, right? So we can rewrite that in standard form. When we do write that in standard form or multiply it out via the FOIL method or box method or whatever method you use, revenue is equal to negative 100x squared plus 1,000x plus 120,000. We do know that that maximum of the revenue is going to occur when x is equal to negative b divided by 2a. So that will be negative 1,000 divided by 2 times negative 100. 1,000 divided by 200 is 5, and so x is equal to 5. Now be careful, x equals 5 is not the answer. So we asked for how should the toy be priced, right? So we're going to go back to look at the price function here. And in part A, we have an expression for the price. Our price is $30 plus the X value, so that would be plus 5. And that means that the optimum price for the toy would be $35, and that's going to give the manufacturer the maximum revenue. In number 6, we have a charter company providing a plane with a fare of $60 each for 20 or fewer passengers. For each passenger in excess of 20, the fare is decreased by $2 per person for everyone. So what number of passengers will produce the greatest revenue for the company? Remember that revenue is equal to price times the number of tickets sold. So revenue is how much money they are taking in. So if you want, you can create a chart for this one if that helps to organize the information and uncover the pattern. So for this, I'm going to leave this first column blank. We're going to define a variable x, and I'm going to define x as the number of extra passengers. So that would be the number of passengers over 20. So if x is 0, then the number of passengers will be 20. In other words, that's kind of where they're starting, right? And then we are also looking at their fare, or how much the ticket costs. And for 20 or fewer passengers, it's going to cost $60 per person. I'm going to take the dollar sign off of that so that doesn't get in our way. And then in that case, our revenue here would be the number of passengers times the fare, or the total amount of money that they collected. That's 20 times 60. If they have one extra passenger, that means the number of passengers is 21, but let's break it down. If x is 1, then we need to use that 1 to calculate the number of passengers, 20 plus 1. And what happens if I have one extra passenger? The fare is going to be decreased, so subtract 2 from it. Now, if x is 2, that means we have 2 extra passengers, and the number of passengers is 20 plus 2, and the fare is 60 minus 2 times 2, or 60 minus 4. If x is 3, that means we have 3 extra passengers, so 20 plus 3, and the fare is 60 minus 2 times 3. So I hope we can see where this is going. So that means that our number of passengers is 20 plus x, and that the fare is 60 minus 2 times x. That makes our revenue equal to the product of those two things, 20 plus x times 60 minus 2x. And if we multiply that out and write it in standard form, revenue is equal to negative 2x squared plus 20x plus 1200. The maximum will occur when x is equal to negative b divided by 2a, which is negative 20 divided by 2 times negative 2, or negative 20 divided by negative 4, which is positive 5. So let's take a look at the question now. What number of passengers will produce the greatest revenue? So remember, the number of passengers is 20 plus x, so that means 20 plus 5, or 25 passengers would maximize the revenue. And that's all they wanted to know. They did not want to actually know what the revenue was. If we did need to know the revenue, we could take the x value and use it in the expression for the fare, 60 minus 2 times 5, and then multiply the fare times the number of passengers. In 7, we find our friends Luke and Leia trapped inside a room at the space station. The room is 20 meters long and 15 meters wide, but its length is decreasing at a constant rate of 2 meters per minute, and its width is increasing at a constant rate of 3 meters per minute. Let t be the number of minutes since the room started changing sign. So what we need to do here is write an expression for the length. So let's make a table here and see if we can uncover something about this pattern. So when t is equal to 0, our length is equal to 20 meters. Now what's happening? Our length is decreasing at a constant rate of 2 meters per minute. So after 1 minute, we're going to subtract 2 meters from that length. Let's continue our table over here. After 2 minutes, the length is 20 minus 4 because 20 minus 4 or 20 minus 2 times 2 because we'll decrease the length by another 2 meters. After 3 minutes, the length would decrease by 6. And I can go back and I can put in a times 1 next to this one and a minus 2 times 0 next to this one. Hopefully we can see that the length is always equal to 20 minus 2 times the value of t. Alright, we're going to do the same for the width. So our width at t equals 0, or the starting time, starts at 15 meters wide. The width is increasing at a constant rate of 3 meters per minute. So after 1 minute, we're going to add 3 meters to that width. After 2 minutes, we're going to add 6 meters to that width, but I'm going to rewrite that as 3 times 2. And after 3 minutes, add 9, or 3 times 3 meters to that width. I'm going to go back and put in that phantom times 1 and another phantom plus 3 times 0, and hopefully that uncovers the pattern here that the width is always equal to 15 plus 3 times x. Alright, we're going to write an expression for the area of the room in terms of t. Oh, and you know what, I goofed on part B. That should be 15 plus 3 times t, not 15 plus 3 times x. Alright, our area of our room in terms of t is just the length times the width, so that will be 20 minus 2t times 15 plus 3t. And now, of course, if we want, we can rewrite this in standard form by multiplying it out. And if you FOIL and rewrite in standard form, a is equal to negative 6t squared plus 30t plus 300. Alright, does the area reach a maximum for a positive value of t? So what we know is that our maximum is going to occur at x equals negative b divided by 2a. So that will be equal to negative 30 divided by 2 times negative 6. So that's negative 30 divided by negative 12, which gives us a result of 5/2, or 2.5. So the answer is yes, we do reach a maximum at t equals 2.5 minutes. last question asks when the area of the room will be equal to 0. So we can take either one of the equations above in part C and just replace A with 0. I'm going to use the first one that's in factored form because guess what? If it's already in factored form, most of the work in solving has already been done for me. So the area of the room will be 0 either when 20 minus 2t is equal to 0 or 15 plus 3t is equal to 0. But think about what this means. One of those expressions was the width and the other was the length. So does it make sense that the area of the room is equal to 0 if either the width or the length are equal to 0? If we solve the first equation, 20 minus 2t is equal to 0, that's t equals 10. If we solve the second equation, that's going to give us a second solution. That will give us a t equal to negative 5. So when will the area of the room in the context of this problem be 0? That would be at 10 minutes because the negative 5 is before the timer actually started. And number 8, the Utah Ski Club sells calendars to raise money. Their profit in cents from selling X calendars is given by the equation P equals 360x minus x squared. We are looking to determine the number of calendars that must be sold to maximize the profit and what that maximum profit will be. I'm going to rewrite my equation in standard form, negative x squared plus 360x, so that we can see the values of a and b. And so we know that that maximum will occur at x equals negative b divided by 2a, which is negative 360 divided by by 2 times negative 1, and that's going to give us a positive 180. And so what does that represent? That is our number of calendars, right? So it's X calendars. So that's the answer to the first question. Now the second question that was asked is, what will that maximum profit be? So we can find that by replacing X with 180. So negative 180 squared plus 360 times 180, and that value is 32,400. So it looks like our maximum profit will come from 180 calendars and will be a maximum profit of $32,400. Oh yes, it kind of looks like maybe there's a typo in that question. The profit's probably not measured in cents. That really doesn't make a lot of sense that someone would actually use that unit. So I think this was intended to be in dollars. All right, number 9. The number of bacteria in a refrigerated food is given by the function n of t is equal to 20t squared minus 20t plus 120. Now, if you like, you can just cross off that of t. So that's just indicating that n is a function of t, right, using function notation. But if you don't like that function notation, go ahead and just cross it off. All right, and they do give us a domain for t of t from negative 2 to 14, where T is the temperature of the food in Celsius degrees. At what temperature will the number of bacteria be the least? So this time we are looking for a least value. And that kind of makes sense because in this quadratic function, A is positive, which means that this parabola will open upward, which means it's going to have a minimum point. All right, so at what temperature? Well, guess what? T equals negative B over 2A. So that's the positive 20 is the value of the opposite of B, divided by 2 times A, which is 20. And so that's 20 over 40, which is 1/2. And so that would be at a 1/2 degree in Celsius degrees will be the temperature at which the bacteria will be the least. The manufacturer of tennis balls in number 10 has a daily cost of C of x equals 200 minus 10x plus 0.01x squared. And C is a function which is the total cost in dollars. Again, if you don't like that function notation, you can just think of it as C equals 200 minus 10x plus 0.01x squared. So x is the number of tennis balls produced. What number of tennis balls will produce the minimum cost? So that vertex of this parabola is going to happen at x equals negative b divided by 2a. And so that will be the opposite of b, which is positive 10, divided by 2 times a, which is 2 times 0.01, and we can do that calculation. And 10 divided by 2 times 0.01 gives us a result of 500 tennis balls, since x is the number of tennis balls produced. In number 11, a ball is thrown straight upward from the top of a 48 building with an initial velocity of 32 feet per second. These pieces of information are already reflected in this height function that's given to us that describes the height of the ball as a function of t, the number of seconds that have elapsed since the ball was thrown. So we're looking for a maximum height, and we're trying to determine how long does it take. So our maximum is going to occur at a vertex. The vertex will be at t equals negative b divided by 2a. The opposite of b is negative 32, and 2 times a is 2 times negative 16. That's negative 32 divided by negative 32, which is 1. So we've answered the question when t is equal to 1 second. And now we need to answer the question how high. We can find how high by replacing t with the number 1 in this equation right here. So negative 16 times 1 squared plus 32 times 1 plus 40. And that's going to give us a result of 72 minus 16. Sorry, typo, that last term was a 48. So that's going to give us a total of 64 if we do that calculation. So what can we say here to kind of summarize this? Our maximum height is 64 feet after 1 second. So that answers the how high and at what time question.